finally, we are going to be talking about finally before we start, using all this in our calculation is that if you are trying to apply it to a body, just like this body, if you are trying to apply it to a body so that its temperature can increase. Now, the amount of heat you need to add to the body depends on three things. You're trying to increase the temperature, you're trying to apply it to this body so that the temperature can increase. The amount of heat you're going to add to the body depends on three things. One, it depends on the mass of the body. The mass of the body. Now, why? The reason is that if this is made up of the same material, let's say aluminium. Now, look, let's say this is 1 kilogram of aluminium. I know that I need 900 joules of heat to increase this 1 kg of aluminium by 1 degree Celsius. But now, this seems to be more than this. So let's say this is 5 kg. So it means that I will need more heat to raise the temperature of this to 1 kg. I will need, because this has more mass than this. So, and that is why we say the amount of heat you are going to add to increase the temperature of your body depends on the mass of the body. That is number one. Now, secondly, it depends on the type of material that the body is made up of. Remember, water has a specific heat capacity of what? Water has a specific heat capacity of 4,200 joules per kg per degree Celsius. But aluminium has a specific heat capacity of 900 joules per kg per degree Celsius. So it means that it depends on the type of material you are trying to heat. So the amount of heat you are going to apply to a material to increase the temperature depends on, number one, depends on the mass of the body. Two, the type of material. And that type of material is represented with what? Specific heat capacity. Now, finally, it also depends on the temperature rise you wish to achieve. How you want to heat, what temperature you want to achieve, what temperature rise you want to achieve. If you are trying to, let's say you want to heat this body so that the temperature will rise by 50 degrees Celsius, and somebody else want to heat this body so that the temperature rise will be 100 degrees Celsius, the amount of heat that you are going to apply is going to be different from the amount of heat that the other person is going to apply, because the person wants 100 to increase the temperature by 100. So the person will need more heat compared to you that just want to increase the temperature to 50 degrees Celsius. So what we are trying to say now is that what? We are trying to say is that the amount of heat you need to add, the quantity of heat you need to add to a body to increase the temperature depends on three things now. That's the mass of the body, the type of material the body is made up of. You understand? The type of material, which is the specific heat capacity, that's mass of the body, specific heat capacity, and the temperature rise. Now, the temperature rise, I'm going to represent that with, you can use dt, delta t, or you can use delta theta. It's just, a symbol that you like. So let us put that on the board so that we're going to understand it further, and we are going to be able to master the formula so that by the time we are going to be solving questions now, you're going to be able to apply the formula. So this is what we are talking about. So what we are trying to talk about here is that the quantity of heat you need to apply to a material to increase the temperature depends on the mass of the body times the specific heat capacity. I'm not just writing this in full, just a specific heat capacity. You understand? Specific heat capacity and temperature rise. Times temperature rise. Now, I can say mass times specific heat capacity, because the symbol for specific heat capacity is what? The small letter C. Times the temperature rise, I can say dt. Some people or some textbook you see d theta. So anything, anyone you want. You understand? But here I'm going to be using delta t to represent. Now that delta means change. It it means change. Just like I'm saying, delta T is equals to T2 minus T1. Let's say the first temperature is 50 and the second temperature is 20 degrees Celsius. So I'm going to say 50 minus 20. That's just temperature change. Do you understand? Or temperature rise. So that is that for that. So this is our formula we're going to be using to calculate the quantity of heat that is going to be added to a material or a substance. Now, remember, a material, it can be removed from a material. That is, a material can tend to cool down. That is when the temperature reduces. You understand? So that is, you can also calculate the quantity of heat that is being lost by the material using the same formula. So that is MC delta T. So depending on what you use. So the next thing we're going to be doing now is to solve few questions. So I have few questions with me. I'm going to be writing on the board. We are going to look at the questions together, apply the formula. Now, meanwhile, the unit of quantity of heat is joule. You know, heat is measured in joule. So the unit of Q, the unit is equals to joule. Joules. So, or we just use J to represent the unit. Now, I'm going to be writing some questions on the board. We're going to be applying this formula with the previous one. But before I do that, don't forget that the other time we talked about heat capacity or thermal capacity. And we said that I represented thermal capacity using CP like this. And I said the mass times what? Specific heat capacity, right? So now let us look at something. Let us look at this formula. Maybe we can still write the total, which is the quantity of it, total quantity of it. This formula. Let's see if we can express it. We can write this formula, this quantity of it, in terms of what? In terms of thermal capacity or heat capacity. So we just say Q is equals to MC dt. But MC is equals to what? Thermal capacity or heat capacity. So I can say Q is equals to CP dt. So that means I can find the quantity of heat even if they did not give me the mass and did not give me the specific heat capacity. That means, and maybe they've already calculated it for me and they just give me the what? The thermal capacity or heat capacity. So what I'll just do is to multiply by the temperature rise to get my what? Quantity of heat. That is it. So please, let's try to write down this formula and try to remember this formula because we are going to be using them now. Now, I'm going to write those questions on the board. We're going to solve and I'm going to give practice question. And meanwhile, those practice questions, I'm going to do the solution in my coming videos. So let us do that now and solve those questions together. So example 1, if 2 kg of water cools from 70 degrees Celsius to 20 degrees Celsius, how much thermal energy does it lose? So this is the question. If 2 kilograms of water cools from 70 degrees Celsius to 20 degrees Celsius, how much thermal energy does it lose? But we know that when the temperature increases, the body is gaining its energy. But when the temperature decreases, it means the body or the material is losing its energy. So that is why the body is cooling down from the temperature of 70 degrees Celsius to 20 degrees Celsius. So we want to calculate how much energy, how much thermal energy it loses. So, and that is what we are going to do. But now, when you're trying to solve questions in physics, it is important that you cultivate the habit of bringing out your parameters, and you should understand what the question is asking of you. The question is asking us to calculate the quantity of heat that the body is losing. So, and I know that, quantity of heat, it means Q equals to mc delta T. Also, I can say Q is equals to thermal capacity times temperature change, or temperature difference, or temperature rise. So I'm going to write out my parameter to know which of the formula is going to be suitable for me. So here I'm going to bring out if 2 kg. If 2 kg means, so my solution is that 2 kg means that the mass is equals to 2 kg. Another thing I'm going to tell you is that this is kg and I'm okay by it. But if they should give me grams, I must change it to kilogram. Remember, those are units. It is very important that you remember that. So this is kilogram, it's okay. Now, of water cools from 70 degrees to 20 degrees. So I'm going to calculate my temperature rise, or my temperature change, or my temperature difference. So temperature difference is going to be what? 70, because I'm finding positive difference here. We don't need minus. I'm just looking for positive difference. So I'm going to say 70 degrees Celsius. I don't need to put the units for simplicity. Ordinarily, we should be putting the units. But for simplicity, let's just say, I'm going to say 70 minus what? 20 is going to give us what? 50. So degrees Celsius. So that means my temperature rise is going to be 50 degrees Celsius. Now, how much thermal energy? So the heat energy, it means that it's asking me for Q, the total quantity of heat. How much thermal energy? It's part of your unit. That's what you are looking for. So you must write it out. Does it lose? Now, then I will look at something that, what about specific heat capacity? They don't give me specific heat capacity. But I told you the other time that this is water, so you should be conversant with it. Don't say, they do not give me every time. As a student, you should know some things offhand. So I'm going to write it myself that, okay, whenever they do not give me, I don't need you to give me. As long as I know it is water, then I'm going to know that the specific heat capacity of water is equals to C is equals to what? Is equals to 4,200 joules per kg per degree Celsius. So, and that is exactly what I'm trying to talk about. Do you understand? So now I can calculate, I can substitute, I know the formula that is suitable for this, because they did not give me its capacity. So they gave me mass, temperature difference, and or temperature rise, and Q is there, and then C. So the formula to apply is Q is equals to mc delta T. So I will just put all of this into this, and I'm going to solve. And remember, you can be asked to, once you know your formula, you can be asked to find anything. Your own is write the parameter out. The one that you are given, put them there. The one that you are not given, put the variable, and then you know what you're looking for. So here, I'm not given Q, it's the one I'm looking for. So I'm going to write my Q again, equals to the mass. The mass they have given us is what? Is 2 kg. So that's going to be 2 times, what about C? That's 4,200. I'm not going to put this because for simplicity. So I'm going to write delta T, which is 50. So everything is going to be in joule. So this is, now, do you know some people can still fail this, not because they don't understand it up to this level, but because perhaps they may make mistake in their multiplication. They're not really good at mathematics like that. So that's the problem of some students. So you need to work on that. So I can choose to do the multiplication of this anyhow I like. So you can use the calculator to do it yourself. So here I'm going to keep this 2 0 and this 1 0, making 3 zeros. So I'm going to multiply 2 times 42, and that's going to be what? 80 what? 84. 2 times 2, 4. 2 times 4, 8. I'm going to multiply with this 5. So 5 times 4 is what? Is 20. So I'm going to write 0. I'm going to keep 2. 5 times 8 is 40 plus this, that's 42. So meaning that 420, I'm having 420 for this. So I'm going to write 420, but 2 zeros and 1 0. So I'm going to write 1, 2, 3. So that is 420,000 joules. That is the quantity of heat that it has lost. Now, this in an exam, they can put this in kilojoule. So if you want to put this in, because it's too long, it's actually too long. So I can decide to put it in kilojoule, higher units. So what I'll do is I'm going to divide it by 1000 to put it in kilojoule. So if I divide by 1000, it will cancel this 30. So I'm going to have 420 kilojoule. Or in some exam, they can actually put this in standard form. So I'm going to just say, if I want to put my answer in standard form, I'm going to say 1, 2, 3, 4, 5 until it remains one number at the front here. So I'm going to write it as 4.2. Now, all this, after the decimal point, I don't need all these zeros again. So I'll just say times 10. 10 must be there. Then how many times? 1, 2, 3, 4, 5 times 5 raised to power 5 what? Joule. So that is the ways that you can write your answer, and that is the answer to this question. Now, what you have to always understand is that we just try to get an experience from each question. I can reframe this question. I can give you the energy now, and I will not give you mass. I will give you temperature change, and I may not give you specific capacity because you should know that, or I can give you. Then I will ask you to find the mass. It's just a rearrangement of the equation. So just division, divide both sides, and that's what we're going to apply. So we can reframe this question in another way. So your aim is write out the parameter, substitute, then apply mathematics to solve the remaining question. So that is that. So